International Trucks is proud to introduce its newest engineering development, the 1978-79 electronic ignition system. This system features a new distributor designed to provide durability and compactness as a unit. The system is now standard on the Scout line and will become standard on IH medium and heavy-duty gasoline engine trucks. Prior to this year, the electronic control unit operated as an independent part. Poor connections from heat and vibration could cause this unit to have operational problems. With our new ignition system, the electronic control unit is located within the distributor. The result, a decrease in operational problems and a more simplified service operation. The new system consists of two major components, the ignition coil and the distributor. The ignition coil is the standard coil used prior to this year. The new distributor consists of a trigger wheel, a sensor, and located under a mounting plate is the new electronic control unit. These new components replace the distributor cam, breaker points, and the condenser. Let's take a closer look at this new electronic control unit. The unit itself is merely an electronic circuit board with the distributor plate assembly and sensor mounted on top of it. The circuit board is a solid-state unit, permanently sealed to resist moisture and vibration. The sensor is a metal detector. The dark spot embedded in the sensor is the sensing coil, which detects the trigger wheel teeth. The leads from the sensor are directly soldered to the circuit board. The direct connection is a major improvement, avoiding connecting problems in the primary low-voltage sensor circuit. There are two circuits in the electronic ignition system, primary and secondary. First, take a look at the primary circuit. The primary circuit is the low-voltage circuit. The electronic control unit is associated with the primary circuit. Rotation of the trigger wheel makes and breaks the primary circuit. The 4-cylinder engine will have 4 trigger wheel teeth, while the 8-cylinder engine will have 8. The dwell angle is determined by the angle between adjacent teeth of the trigger wheel and the air gap between the ends of the trigger wheel teeth and the sensor. Set the dwell between 26 and 32 degrees. Once the dwell is set, it will remain constant. To determine the air gap, first position one of the trigger wheel teeth so it is perpendicular to the face of the sensor. Using a feeler gauge, the air gap between the trigger wheel tooth and the sensor must measure 0.008 of an inch. Now that you've seen its components, let's see how the electronic ignition operates. To start, when the ignition key is turned on, an oscillating signal is set up in the sensor circuit. This signal creates a field around the sensor. As a trigger wheel tooth enters the sensor's field, the oscillating signal is reduced in strength. This weakened signal is detected by the demodulator, which regulates a transistor or power switch to break the current in the primary circuit. Breaking the current in the primary circuit induces high voltage in the coil and secondary circuit. When the trigger wheel tooth leaves the sensor field, current is restored to the primary circuit. Now, let's take a look at the primary wiring for the distributor. The red wire connects to the coil positive terminal. The brown wire connects to the coil negative terminal. The white wire connects to the deceleration throttle modulator. On vehicles where electronic governors are used, there is a wire between the governor and the coil negative terminal. Because the primary current is regulated within the electronic control unit, a ballast resistor or resistance wire is not needed. Taking a closer look at the red and brown wires, you will notice that they are now designed with I terminals. Unlike the male-female connectors of previous years, these terminals are more resistant to heat and vibration. Moving to the secondary circuit, the components are the coil, the distributor cap, the rotor, high-tension cables, and spark plugs. The new distributor cap features superior physical strength, as well as improved dielectric or non-conductive qualities. The male terminals are an improvement over the previous plug-in type. The resistor type rotor, the interference suppression type high-tension cables, and the resistor type spark plugs are used to meet radio frequency interference standards. As with previous distributors, the new distributor has two spark advance systems. The mechanical or centrifugal spark advance system advances the spark as the engine speed increases and retards the spark as the engine speed decreases. The vacuum spark advance system responds to changes in carburetor throttle bore vacuum. Before we go any further, you can find information on servicing the electronic ignition system here in the IH Truck Service Manual. The 1979 service information will be issued concurrent with 79 vehicle and engine releases. Refer to 1978 Electrical, Section CTS 2740, or 1979 Electrical, Section CGES 145, for information on the Prestolite distributor with the Integral Electronic Control Unit numbered IDN 4000. For information related to the ignition system, refer to the fuel system sections. For information regarding emission control systems for gasoline engines of 1978 vehicles, refer to Section CTS 2733. For the Scout emission control systems for gasoline engines of 1979, refer to Section CTS 2751. And in the near future, you can refer to Section CGES 135 for information on the heavy-duty emission control systems for gasoline engines of 1979 vehicles. Before we view the next section on troubleshooting the electronic ignition system, take a few moments and complete the exercises from the reference guide that accompanies this program. Concurrent with the 1979 vehicle and engine release, International Harvester will be issuing a new inspection form, numbered CGED 170. This form is designed to help you in troubleshooting the electronic ignition system. There are a few items of test equipment that are required to properly perform the techniques for troubleshooting the electronic ignition system. They are a DC voltmeter, an insulated pliers, a timing light, a jumper wire, and an ohm meter. The troubleshooting procedures are used to isolate which of the components must be replaced and why. Prior to testing the electronic ignition, the mechanic must first eliminate the fuel system and evaluate the engine condition as a possible cause of the problem. Now, the first troubleshooting step is to test the battery voltage. Start by connecting the voltmeter to the battery. The voltmeter should read 12 to 13 volts. If it doesn't, you have two alternatives. Charge the battery until it maintains a 12 to 13 volt reading, or replace the battery. The next troubleshooting step is to test for spark at the spark plug. Start by disconnecting a high-tension cable from one of the spark plugs. Always use a twisting motion when removing the plug cables to avoid damage to the resistance wiring. Then, insert an extension adapter into the boot and engage it in the cable terminal. Hold the plug cable with the insulated pliers and create a half-inch gap between the extension adapter and the engine. Now crank the engine and look for a spark across the gap. If a spark occurs, the ignition system is functioning. When you have a spark at the cable terminal, you must check elsewhere for the problem. Check the spark plugs and ignition timing. Then recheck the fuel system and the engine condition. When there is no spark at the plug, your next step is to test for spark at the distributor cap. Start by disconnecting the cable from the center tower of the distributor cap. Then insert an adapter into the boot and engage it in the cable terminal. Hold the cable with the insulated pliers and create a half-inch gap between the cable terminal and the engine. Crank the engine and look for a spark across the gap. If a spark occurs, the problem is in the distributor cap, the rotor, or the spark plug cables. If there is no spark, you can move to the next step, checking the trigger wheel to sensor air gap. Start by removing the distributor cap, rotor, and shield. Then align a trigger wheel tooth with the sensor. The trigger wheel tooth should be perpendicular to the sensor coil. Check the air gap between the trigger wheel tooth and the sensor. The correct gap measurement is 0.08 of an inch. If the air gap is out of specifications, adjust the air gap to 0.08 of an inch and retest for spark at the distributor cap. If there is still no spark at the distributor cap, you can move to the next step, testing the primary voltage. Begin this step by rotating the distributor shaft until 2 trigger wheel teeth bracket the sensor coil. Then connect the voltmeter between the coil positive terminal and the ground. Turn the ignition to on and observe the voltmeter. If the voltmeter reads 12 to 13 volts, you can proceed to the next troubleshooting step. If the voltage is noticeably lower than 12 to 13 volts, a resistance exists between the battery and the coil. This problem must be located and repaired. To locate this problem, you must perform the primary voltage drop test. Start by removing the distributor cap, rotor, and shield. Rotate the distributor shaft until 2 trigger wheel teeth bracket the sensor. Then, connect the voltmeter positive lead to the battery positive terminal, and the voltmeter negative lead to the coil positive terminal. Now turn on the ignition. The reading should be less than 1 volt. Finally, check the circuit conditions by moving the connectors at the battery cables, starter solenoid, battery terminals, firewall connector, and the ignition switch connections. If you notice any fluctuations of the voltmeter reading, a poor connection exists and must be corrected. Before we go any further, stop for a few moments and complete the exercises in your reference guide. In the reference guide, you will find a flowchart on the material we have just covered. The next troubleshooting step is to test the voltage at the coil negative terminal. Start this test by once again rotating the distributor shaft until 2 trigger wheel teeth bracket the sensor coil. Then connect the voltmeter between the coil negative terminal and the ground. Turn the ignition to on and observe the voltmeter. If the voltage reads 5 to 8 volts, you can move to the next troubleshooting step. If the voltage reads 12 to 13 volts, there is a series of steps that must be taken. First, connect the jumper wire between the distributor and the battery negative terminal. Here, the jumper wire has been banded to make it easier to identify. Then, turn the ignition to on and observe the voltmeter. If the voltage remains at 12 to 13 volts, the electronic control unit is faulty. If the voltmeter reads 5 to 8 volts, the problem is in the ground circuit between the distributor and the battery. Now, if you get a reading of 0 to 5 volts, there is an alternate procedure to follow. Start by checking the distributor to coil wiring. Then disconnect the voltmeter and remove the brown wire from the coil negative terminal. Reconnect the voltmeter between the coil negative terminal and the ground. Turn the ignition to on and observe the voltmeter. If the voltage still reads 0 to 5 volts, you have a faulty coil. If the voltmeter reads 12 to 13 volts, the problem is in the electronic control unit. Now the next step is to test the electronic control unit operation. Start by connecting the voltmeter between the coil negative terminal and the ground. Turn the ignition to on. Place a screwdriver blade against the face of the sensor. The voltage should read 12 to 13 volts. When the screwdriver is removed, the voltage should drop to a reading of 5 to 8 volts. If the voltage does not move up and down, the electronic control unit is faulty. If the voltage does move up and down, you can proceed to the next step, testing the coil operation. To test the coil operation, start by connecting an extension adapter to the coil high-tension cable terminal. Then re-establish a half-inch gap between the adapter and the engine. Turn the ignition to on. Look for a spark when a screwdriver blade is placed against the face of the sensor. If there is no spark, the coil is faulty. If a spark does occur, the next troubleshooting step is to do some rechecking. Start by disconnecting all of the test equipment and replacing all of the components. That is, reinstall the shield, rotor, and distributor cap, and reconnect the coil high-tension cable to the distributor cap. Then recheck for spark at the spark plug. Next, connect the dwell meter to the engine and observe the dwell reading. If it is necessary, readjust the trigger wheel to sensor air gap to obtain the specified dwell. Then disconnect the vacuum hose from the distributor and connect the timing light to the engine and check the timing. If it is necessary, adjust the timing. Now before we continue any further, the projector is going to stop. When it does, go to your reference guide and complete the exercises. Once again, you will find a flowchart on the material we have just covered. Before condemning any of the electronic units, the secondary system components must be checked. That is, check the distributor cap, rotor, coil, cables, and plugs for possible damage. If you detect cracks, carbon tracking, loose terminals, dirt or contamination, clean them if possible, or replace them. The next step is to test the rotor resistance. Check the rotor blade and spring for tightness. Also, check the fit of the rotor on the trigger wheel shaft. Using an ohm meter, check the rotor resistance. If the resistance is over 6,000 ohms, replace the rotor. Let's now see how to test coil resistance. Start by removing the primary leads and the secondary cable from the coil. Then set the ohm meter in the ohm times 1 position. When you connect the ohm meter between the coil primary terminals, you should get a reading between 1.2 and 1.4 ohms. Then set the ohm meter at the ohm times 1000 position. When you connect the ohm meter between one of the coil primary terminals and the coil tower terminal, you should get a reading between 9,000 and 12,000 ohms. If the coil doesn't meet the requirements, in both instances, replace the unit. The next test is to check the secondary cable resistance. Start by again checking the condition of the components. Inspect the cables for deterioration, carbon tracking at the terminal booths, and for high voltage leakage. Then check the resistance with an ohm meter. The resistance should be under 30,000 ohms for cables up to 36 inches long, and under 45,000 ohms for cables longer than 36 inches. Check the boot sealing on the distributor cap, coil tower, and spark plugs. If they look defective, replace them. Clean the cable terminals and apply a light coat of IH lubricant, numbered 472-141-C1, to the terminals. Finally, make sure that all the cables seat properly and check the ignition cables for proper routing. Inspect the primary circuit by checking the ignition wiring, repairing any loose connections, and replacing any frayed wires. Now, if your tests indicate that the electronic control unit is faulty, there is a simple procedure used to replace it. First, remove the distributor from the engine. Next, remove the E-clip, felt washer, and the vacuum advance unit from the distributor. Then you can remove the control unit. First, remove the distributor plate retaining screws. Then carefully pull the wiring grommet from the slot in the housing. Then lift the control unit out of the housing. To install the control unit, lift the upper advance plate and lubricate the 3 thrust buttons under the plate with a premium quality grease. Position the control unit in the distributor housing, then position the wiring grommet in the housing and reinstall the retaining screws. Reinstall the vacuum advance system. Adjust the air gap to 0.08 of an inch. Install the distributor in the engine and check the dwell and timing. That covers the operation and troubleshooting procedures for the 1978-79 electronic ignition system from International Truck. Take a few minutes to complete the last section of your reference guide. When you have completed the last section, restart the projector to conclude the program. For more information on the electronic ignition system and other topics, enroll with your nearest International Truck Training Institute. International Harvester is proud to offer you the latest in truck technology. With more compactness and durability, this new electronic ignition system offers less chance of malfunction and a more simplified service operation. It's 1978, and we mean it when we say, we're better than ever.